academic minute.
No, let's go. I think the people coming in, and please start introduction.
Yeah. Hey, and good morning. My name is. It's our second presentation webinar today, and I'm pleasure to present ESSVE or ESSVE Academic. This the second webinar, or the second presentation. We will talk about the ROP effect, and it will be Eero from Tallinas University, and then it will be Enno will talk about our ESSVE and how the communication between this the theory and the practical can connect it. This is the agenda for today, and if we start with poll questions, Enno, can you pull it up, the poll question?
Yes, I can release the first poll. It's loading, and here we go.
It was interesting for us to know how many has participated the first time and who is this the second time. Please answer this question. It's very clear. It's the 93% is the second time. Maybe it will be more or less. It's very interesting. Therefore, when we talk about the intro, it will be very quickly that for who not was with us the first time, we can say some more about ESSVE. If you know, ESSVE is the leading fastener company, and we founded in Sweden, or founded in Sweden for 1917, and we have company in 7 Europe countries. We are more than 200 employers, and we are a part of the Bergman och Bevings group. And just for imagine how big ESSVE is, we sell almost 5 million screw every day. If we want to talk about our application, we have four main application. We have foundation and structure, this part one, and we have building a secondary buildings part, which is wood, roof, and insulation. The third one is finishing, and the fourth one is outdoor. But as we now, like structure engineer, we are most interesting about the part one, which is a foundation and structure. And in foundation and structure included our the second webinar, which about the timber structure connection, and we have further that we have concrete connection too, but it will be in the further in the future we will talk about it. If I leave the presentation to you, Eero, please.
Thank you.
Yes.
So I will share my screen. Can you confirm that you can see my screen? Thank you. So good morning. Nice to be here again. second time. And who doesn't know, we agreed with ESSVE that in parallel with this ESSVE Academy, I will talk about with 10-minute slots about new Eurocode to not give you too much overwhelming information. I will keep the topics very short. And today's topic is a second part of laterally loaded connections and the rope effect. So first, I will talk about what is rope effect and how we can use the benefits of it. As we know, in Eurocode, the laterally loaded connections are calculated according to Johansen model. Johansen model was developed already in 60s, last century. And these are basically equilibrium equations. It takes different failure modes of laterally loaded connections. And these formulas we are seeing in the Eurocode, these are equilibrium equations. And these are somewhat modified according to Johansen's original model, because in the Eurocode we have to also cover the partial safety factors, and partial safety factors for steel and timber are different, and therefore some additional coefficients are here available. But also we have in this blue box so-called rope effect. Rope effect can add additional load carrying capacity to the connection, and the rope effect is actually there when the failure mode is like this. If we have inclined connection or inclined fastener in the connection, and if this inclined fastener is taking also or also has withdrawal capacity, it means that we cannot pull it out from the timber. Then this fastener has a tensile force in it, and this tensile force will have two components, and the first component is additional load carrying capacity, which is very small. This is due to the inclination. And the other component is horizontal, and this horizontal component will cause friction between two timber parts or between steel and timber, and the friction coefficient is 0.25, and that's because in the formula there is a FAX, it's withdrawal capacity divided by 4. It's reflecting this this friction force. But in Eurocode, first generation Eurocode, this with rope effect is expressed a little bit confused way. But in the second generation, there is rope effect reflected much more clear. And here on the right side, you can see how it's handled in the second generation. This is the load carrying capacity of the connection, and this is divided in two parts. So the first part is towel effect contribution, which is basically the Johansen formula. These all remain the same in the second generation, but the rope effect contribution is the second part of this formula. So the double effect contribution we handled the same way as we did until now, and we can, this double effect contribution is available for every type of fastener, but if we are using, let's say, dowels or smooth nails, then this rope effect is not there, because these fasteners don't have too much withdrawal capacity. But the rope effect contribution, this formula is divided in two parts to make it more clear how to handle that. And the first part here is FAX, so this is the withdrawal capacity, multiplied by this friction coefficient. And this friction coefficient is the same as we know from the first generation of Eurocode, but we also have additional coefficient for ring shank nails and coated staples. These connections show a little bit higher friction between the timber members because of this embedment failure under the nail, and we can get the benefit from this type of connections. And the second part is rope effect limitation, and the rope effect limitation means that we are not allowed to take the rope effect contribution higher than this towel part. So the towel part is this FDK, so as we saw here. And in new Eurocode, it's clearly said that we have to limit this part here. And if we check one small example, you can see here the example for screws. In the screw, we can use 100% of towel contribution. And here under, you can see two different examples. And the first one, let's say we have a connection where the dowel effect contribution is 2 kilonewtons and the withdrawal resistance is 6. This is the rope effect part. Then we find this friction part. We divide this withdrawal resistance divide by 4, and we get 1.5 kilonewton additional load carrying capacity. And this is smaller than the dowel effect contribution. And for screws, it is allowed 100% of this, but we don't reach the 100%, and we can use all of this dowel effect contribution, and we get the total load bearing capacity 3.5 kilonewton. Here is a small mistake. On the right side, there is a situation where the dowel effect contribution is the same, but the withdrawal resistance is higher. It means that we have a longer screw, or screw has better withdrawal capacity, and we get this rope effect part 2.5. It means it goes bigger than the dowel effect contribution, but the table allows us to use only 100% of the dowel effect contribution, and that's because the total load bearing capacity is 2 + 2, so we cannot allow add all what we get from this withdrawal part. So this, if we use all of them, we can design the connection in the wrong way, that we have very large deformation in there, and we cannot go over this dowel effect contribution limit. So this is all for today. Next time we are speaking about this withdrawal capacity itself. So how to find this withdrawal capacity according to new Eurocode, and what is new there. So this is all from my side. It's exactly 9 minutes and 40 seconds.
Thank you, Eero, for the great presentation. If you have any question, you can send it to us or you can send it to Eero directly. And now is the second part of the presentation, and Eero, the screen is yours.
Hello from my side. My name is Enno Rahuoja. I will talk about a little bit how you can calculate it. It's going to be a demo of ESSVE calculation program. And before we go there in it, we last time lightly introduced that we have also the concrete calculation program. If you need to fix the timber to concrete, we are not stopping thereby. And to just talk about wood, then the wood is the preferred area, the day's subject. And I have opened up here Lithuanian website. I hope everybody can see that. We are going to enter in. If somebody shows the thumbs up, then I know that we are in. I will show the Lithuanian website here, then everybody can switch here the languages. And best way to get it in is you choose the construction engineer. You go for timber. In the timber area, you roll it down and you find also needed info. But today we are not going to stop by there. You will open up calculation mode. In calculation mode is also for new beginners, just sign up, and log in is for already existing users. You will see here also your previous projects, where you have done it. So I have prepared one of the calculation here for the day's, let's say, CLT Academy to just win time. And in this academy part, you are able to have different way to make your connections. As last time we were talking about timber to glulam, you are also option to choose glulam to CLT or metal to glulam or metal to CLT or metal to timber. You can have also two metal parts here to fix it, and when we go to timber connection, you can have it also with one fastener connection nicely in. So let's look at the day as a CLT application. You can choose here, is it a 45 degree or 60 degree connection? I will probably demo you a 90 degree connection. Here you can add in that timber parameters. You will see that the parameters will be visualized also here on the drawing with the red mark. So you know that's the thickness of the wood. We can add here also the width of the wood. We can choose that the wood is not glulam, but it could be a timber. Timber, you can also add here a quality class in it. That measurement is important, especially when you do the angle connection, that it's long enough that it passed the member of a construction element. Here you can choose then, is it a glulam or a timber connection on main construction area, or it could be also a CLT area. Now, when we choose the CLT, in GLT area, we are able to also locate the timber. So we can locate it, is it horizontal on visible level, or is it a vertical in visible level? You can also add here layers. Let's say we do it. We are in 5 layer level. And if we talk about here in a differentiation, you can also have a different thickness of the layer. I will take that as a sample. Then you can have those also not harmonized. So they are always horizontal and cross, but you can do it different way. And when you have chosen so that it's a, let's say, not harmonized connection, then you are able to here also select different thicknesses, let's say That could be 40, and you can choose here a timber. Another one could be 50, maybe. So you could use the timber what you want. Normally here you're gonna use it thinner one. You can have different quality levels in it. So you will get your specification, and if you want it, you can also rename it with your brand name. So it's in the future easy to pick it up as a favorite option. Here in subframe construction, fixing to the main beam or element, you can choose also, is it a pre-drilled hole only for fixing material, or is it a pre-drilled hole for whole screwway? Which is also a positive thing here. You can also choose here, for example, in thicker construction elements, that you will hide the fastener head in it. So it will take it in the calculation as well. So if you wanted to make it, let's say, fireproof fixing, hide the connection in the wood, put the wooden plug on the top of it so you don't have any fixing visible, then you can bring that as well in the calculation. I, at the moment, leave it out because we have so thin wood. We have only 45, but if you're gonna have a thicker one, we could use that. Then the fixing point itself, is it a cross or is it zigzag or lined up? And here you will choose your service class. Is it 1, 2, or 3? So if you're gonna have in external protected area, it's normally 2. If you wanted to change the direction of the load, at the moment is downwards, then you can change it to 0, for example, and then it goes upwards, or you can change it to 90 degrees, then you go sideways, so it's up to you. Let's say we're gonna have at the moment the sub element 180 degrees, which is pushing that load downwards. Then you put your design elements, and when you're gonna have the axial load as well, then the axial load will come visible here with the arrow point. So you will find it there as well. And this is the way you will get it. And you have another option as well, where you can select, if you already know that I want to use only a hex head, then you leave the rest of them out. If you wanted to leave it out, for example, here all the pan heads on that connections, then we can do it. We make in here a design. And it brings you a whole lot of fasteners to the selected choices. Let's put it so that I will look here a little bit closer. So you will see that I want to have a more safer connection, which means that it's not only done with 2 fasteners. I want to have maybe more fasteners in it. Then I can look at here 4 or even 6 fasteners. Let's say I will select it here 6 by 100. Then you're gonna have here also opportunity to select which way you do this connection. So you're gonna have it choice of 3 fasteners, or you can have it 4 fasteners in a row. So you are able to make here also selection which way you wanna have those connections visualized here. There is also another option that in the top level, that if you wanted to select here that in the filter area that I'm gonna choose only a 6mm screw or only 8mm screw, you can do it also here already. So we stick here at the moment with diameter 6, and we are going to see what is the report area. Before we go to report area, I say that you can also customize here to put the project name in, what is the address. You can also add here a customer name in it, and then you will do your report printout, and the report printout you can deliver it and save it for your archiving. So this is how the report will look. You will see here the needed info. You will see also the info about the side member and main member. You're gonna now see also the loads and directions and fastener properties. If you go below, you will see what the document paste all the calculation is made of. This sheet, you are able to deliver your construction site, so the installers know how to make the correct installation. Here will be also the parameters in pre-drilling. And here is the info on the technical side, what engineer all needs. Basing on the time, the day, I'm not going in the details, but you are ready to come back, ask all the questions. Eero touched points, all are in here. So you are able to do your checks, controls. Previous time, Eero was also talking about the safety modes here with the ABCDEs. So when you choose or select a different diameter of fastener, you will get out also different result. From my side, yes?
Enno, if you scroll up a little bit, a little bit down, more.
You mean here?
Here, yeah. What's the important that understand? We have the rope effect, which Eero is talked about. Is it like that? You see that you can just pick on it. It's 4.212 there, and we divided by 4, and we get 1.05 kilonewton per for every screw, for every fastener. If you scroll down a little bit to the result, here you see up, but here you can see from FV from 8.68 A to 8.6 F. You see the last 4 one, you have almost 1.5 kilonewton, 1.05 kilonewton external capacity for every screw, which means you will get almost 30% extra capacity. And when you see you have almost 10 screw, you will get almost 10 kilonewton extra capacity, which is very great when you do your calculation at the optimization for the connection. It will be much less than if you ignore the rope effect. And if you scroll up a little bit, Eero,
Yes.
a little bit more up, more here, down, down, here you see how the calculation is did for the rope effect. We take the mini capacity from F withdrawal capacity, the first one, and the F pull and the F tensile. If you have 4-threaded screw, it's almost the FIX withdrawal capacity will be the down, which was 4.212. This would be the value which decide the capacity for the rope effect. And can I say, the withdrawal capacity value is depend on which test every company has done. If you take, we will be responsible for the FIX withdrawal capacity that we have in ESSVE. And because of that, you get the final result with almost 30% more capacity for every screw.
Thank you, Tiar. We are in a time limit period. It's 30 minutes past, but please write up some questions if you have. I will release also one poll to you, which is related how many of you have been already using it next time, probably, or the time after that, we will ask how do you feel and get the comments. So please, you can choose here your answer and release it for us. I personally will come back and hand over to you, Tiia, to take the screen and finish the day's Academy Day. Thank you from my side. You are welcome to call me. Tiia, do you want to do some slides of presentation more, or I will raise it here, the question field up, so everybody can stick on that.
Yeah, I just want to say that our next webinar, it will be on the 20th of April, is about the axial load connection, and after that in the 8th of May it will be the axial load connection part 2, and if you have any questions, so you can please contact us. I'm structural engineer, or my colleague Radik, or Enno.
Mm-hmm.
Yes.
So we have hopefully some questions as well.
Mm.
Do you see as a moderator some questions?
No, we don't have any questions.
Okay.
There is a remark that 20 is Sunday.
Okay. Then, yeah, that is April 24th. So it's
17th of April is the next one.
Thank you. Any questions to Eero? If you don't have a question, it's 10:33 and we plan at the 30 minutes Academy today. So I call it then thank you very much, and we'll be saying see you next time. That's it.
Thank you. Bye.
Thank you very much.
Yeah. Bye.
Bye.